Hello everyone, I am Nagraj S. Kumbarwaka, lecturer of Computer Science and Engineering Department, Jain Polytechnic, Belagavi. In this video, we will learn about introduction to the design and analysis of algorithms. That is, first we are discussing what is an algorithm and then fundamentals of algorithmic problem solving. What is an algorithm? Right? An algorithm is a sequence of ambiguous instructions for solving a problem, that is, for obtaining a required output for any legitimate input in a finite amount of time. As the diagram shows here, the notion of algorithm, the reference to the instructions in the definition implies that there is something or someone capable of understanding and following the instructions given. We call this a computer. Keeping in mind that before the electronic computer was invented, the word computer meant a human being involved in performing numeric calculations. But nowadays, of course, computers are those ubiquitous electronic devices that have become indispensable in almost everything we do. However, that although the majority of algorithms are indeed intended for eventual computer implementations, the notion of algorithm does not depend on such an assumption. As the notion of algorithm indicates here, that computer is performing something, that is, after the problem definition is defined, we will be writing the algorithm for that particular problem. Once the algorithm is completed, we will be coding it and we will be executing all the instructions of that particular problem, of that particular algorithm with the help of computer. Then the computer will be, depending on the situation, computer will be accepting the input from the users. Once the user uses the input, it will be processing that. Then after processing, whatever results comes, it will be providing us as output. This is all about the algorithm. Next we will see methods for solving the problem. That is, we have Euclid algorithm to solve the problem, then consecutive integer checking algorithm, then middle school procedure. I am considering here one example, and for that particular problem or for that particular example, we are applying these three methods for solving that particular problem, that is Euclid algorithm, consecutive integer checking algorithm, and middle school procedure. That is, the example is computing the greatest common divisor of two integers. We will see, if you apply Euclid algorithm for that particular problem, what steps it will take and what is the pseudo code for that particular problem, computing the greatest common divisor of two numbers, that is m and n. So here we have Euclid algorithm for computing GCD of m comma n, that is we are taking two common variables like m and n, and with the help of GCD function we are solving that. In the first step, what we are doing, if n equal to 0, of course we have to consider two numbers m and n. That means if n equal to 0, return the value of m as the answer and stop it. Otherwise, proceed to step 2. That is, divide m by n and assign the value of the remainder to r. That is, dividing m by n. One number should be divided by another number and assign the value of the remainder to a variable called r. Then assign the value of n to m. Assign the value of n to m and the value of r to n. Go to step 1. Again, if n equal to 0, return the value of m as the answer and stop it. Otherwise, again proceed to the step 2. Again do the same operation, divide by m by n and assign the value of the remainder to r. Again assign the value of n to m and the value of r to n. Then go to step 1, again verify the value of n. Here pseudocode indicates that not exactly coding here, it is just a code that computer GCD m comma n by Euclids algorithm. It is not computer, compute GCD m comma n by Euclids algorithm. And what inputs we are giving? Two non-negative numbers, that is not both zero integers m and n. Then output should be in such a way that GCD of m and n. While n not equal to 0, it is not equal to 0. While n not equal to 0, do these operations. What operation? m mod n, whatever results come, whatever remainder is coming, we are allocating that value to variable r, and m equal to n. Whatever n value is there, whatever we saw here, step 1, 2, 3, the same is represented with the help of this pseudocode, and we are assigning n value to m. Then n r value to n, whatever remainder is there, again assign it to n, then return the value of m. Then after this, the computing GCD of two numbers, we applied Euclid algorithm. Then if you apply consecutive integer checking algorithm for the same problem, computing the GCD of two numbers, here what it follows here, assign the value of min of m comma n to t. Then step 2 says that divide m by t. If the remainder of this division is 0, go to step 3. Otherwise, go to step 4. That is, if the remainder of this division is 0, then go to step 3. What step 3 is containing? Divide n by t. If the remainder of this division is 0, return the value of t as the answer and stop. Otherwise, proceed to step 4. Decrease the value of t by 1. Then go to step 2. Again perform divide by m by t. If the remainder of this division is 0, go to step 3. Otherwise, go to step 4. If the remainder is 0, then again divide n by t. Again, if the remainder of this division is 0, return the value of t as the answer and stop it. This is how this consecutive integer checking algorithm for computing the GCD of two numbers works. Then if you apply the middle school procedure for computing the GCD of two numbers, here it follows: find the prime factor of m, then find the prime factor of n, then identify all common factors in two prime expansions found in step 1 and step 2. Compute the product of compute just a minute. Compute the product of all common factors and return it as the result. This is how middle school procedure works. And then we have fundamentals of algorithmic problem solving. What are the fundamental things we should know before going ahead for solving a problem with the help of algorithm? So we should follow this particular steps here, that is algorithm design and analysis process. We should follow this particular process whenever we solve a particular problem with the help of algorithm. That is, we have to, first step is understand the problem. What exactly the understand the problem says is, in this process, an input to an algorithm specifies an instance of the problem the algorithm solves. And it also important to specify exactly the range of instances the algorithm needs to handle, and we have to have understand very clearly the problem and clarify the doubts after reading the problem's description. And correct algorithm should work for all possible inputs. That is what the understand the problem step says in this particular process. Then ascertaining, in second step, ascertaining the capabilities of computational device. That is, the second step is to ascertain the capabilities of a machine. Then also the essence of non-Neumann machines architecture, the instructions are executed one after another, one operation at a time, and algorithms designed to be executed on such machines are called as sequential algorithms. Then an algorithm which has the capability of executing the operations concurrently, which is called parallel algorithms. That is about the second step, that is decide on computational means, exact versus approximate solving, algorithm design techniques. That is about second step in this process. The next step is choosing between exact and approximate problem solving. Here the algorithms are classified as exact and approximate. Algorithms are classified as exact and approximation algorithms. As I said here, there are three issues to choose an approximation algorithm. First is, there are certain problems like extracting square roots, solving nonlinear equations which cannot be solved exactly. Secondly, if the problem is complicated, it slows the operation. For example, traveling salesman problem. We'll see this, what exactly the traveling salesman problem in further videos. Then third one is, this algorithm can be a part of a more sophisticated algorithm that solves a problem exactly. And deciding on approximate data structure. Data structures play a vital role in designing and analyzing the algorithms. And also these algorithm design techniques depend on the structuring data, specifying a problem's instance. That is what exactly a program is. It is a combination of an algorithm plus data structure. Algorithm plus data structure is nothing but programs. Then algorithm design techniques. An algorithm design technique is a general approach for solving problems algorithmically that is applicable to a variety of problems from different areas of computing. Then design techniques are important for two reasons. The first is, they may provide guidance for designing for new problems. They provide guidance for designing for new problems. Secondly, algorithms are the cornerstones of computer science. Then methods for specifying an algorithm. What are the methods for specifying an algorithm? As we saw previously in the previous slide, that is pseudocode. A pseudocode which is a mixture of natural language and programming language like constructs. Its usage is similar to algorithm descriptions. For writing pseudocode, there are some dialects which omits declarations of variables, use indentations to show the scope of the statements such as if, for, and while. Use for assignment operations to two slashes for comments. Then to specify algorithm flowchart is used, which is a method for expressing an algorithm. by a collection of connected geometric shapes consisting descriptions of the algorithm's steps. Then proving an algorithm's correctness. Algorithmic verification means checking correctness of the particular algorithm whatever we have written. After specifying an algorithm, we should go for checking correctness, and we normally check whether the algorithm gives correct output in a finite amount of time for a valid set of inputs. Then the proof of correctness of an algorithm can be complex sometimes depending on what problem definition you are having, what algorithm you are writing that particular problem. Then the common method of proving the correctness of an algorithm is by mathematical induction. Then we will go for analyzing an algorithm. While analyzing an algorithm, we should consider some of the factors such as time complexity, space complexity, simplicity, generality. That is, time complexity, the amount of time taken by an algorithm to run. By computing time complexity, we come to know whether the algorithm is slow or fast, how exactly it works. Then space complexity. This space complexity deals with amount of space taken by an algorithm, and by computing space complexity we can analyze whether an algorithm requires more or less space. Then simplicity. Simplicity of an algorithm means generating sequence of instructions which are easy to understand. Generality. Design an algorithm in more general way rather than designing it for particular set of inputs. And then after analyzing the algorithm, we will go for code the algorithm. That is coding, writing the code for that particular algorithm, for that particular problem. The implementation of an algorithm is done by a suitable programming language. Various programming languages like C, C++, Java, Python are commonly used programming languages for implementing the algorithm, implements the algorithms. This is how these all steps taken by this particular algorithm design and analysis process. This is the algorithm design and analysis process. Then we will see what all things we learned in this session. That is, what is an algorithm we discussed, and fundamental of algorithmic problem solving. That is, an important issue of algorithmic problem solving is the question of whether or not every problem can be solved by an algorithm. Before leaving this section, let us be sure that you do not have the micro misconception possibly caused by the somewhat mechanical nature of the diagram that designing an algorithm is a dull activity, and there is nothing further from the truth. Inventing algorithms is a very creative and rewarding process. Thank you. If you are having any doubts, please do ask your queries. Thank you once again.